Hello, everyone. Welcome to the Marmon II podcast with Phil. I'm your host, Phil Laudicina. And today I am very pleased to have as my guest our application engineer for rolling stock and transit, Gil Shoshani. Gil, welcome to the show.
Hello, everyone. My name is Gil Shoshani, and I work for about 20 years with Marmon IEEE. The company recently changed name. We used to call Rockbestus Surprenant or RSCC, and before that it was Rockbestus. This is a very well-known company name. And currently I'm an electrical engineer, application engineer with Marmon IEEE.
Well, it's great to have you here. So today we're going to talk about IEEE 2789. It's a guide which was published about a year ago now, I believe. You were the working group chair. You ran that. I was a part of the working group. And I will say you did a tremendous job bringing that standard to completion. I think it took about 7 years, if I'm not mistaken, 6 or 7 years, right?
Yes, because we had to stop a little bit during COVID.
Well, yes. Yeah, COVID stopped everything. But yeah, and I remember, I believe it started before I even joined Marmon, if I remember right. I was still with my previous company.
Correct.
Yeah. So let's talk a little bit about IEEE. So IEEE is a lot of societies. Which society has jurisdiction over this document?
So IEEE 2789 was developed under PES, Power Engineering Society, and a sub working group to it is called ICC, Insulated Conductor Committee. That's where we meet twice a year and we develop standards and guide like IEEE 2789.
Okay. So what was the purpose of this guide, and what was your reason for basically creating it and feeling there was a need for it?
Yeah, that's a great question. The title of IEEE 2789 is IEEE Guide for Selection and Application of Cable Used in Enclosed Transit Infrastructure. Enclosed transit infrastructure mean cables that are installed in subway tunnels, metro tunnels, and underground station. It does not handle cables that are installed in transit above ground or outside. And the need for this guide is to explain another standard that is called NFPA 130 and how it applies to cable. When you read NFPA 130 and the requirement for cable, they are very specific, but when you start talking to various cable manufacturers, you understand that there are different options to meet NFPA 130. So the guide explains what are the cables that can be used in this type of environment, what is their listings and performance, and the different options. Also, it handles cables that do not meet NFPA 130 but used as a legacy cables and being used in the United States for maybe over 100 years.
This guide is for North America, correct? Not just US.
Yes, most of the transit authorities in the United States adopted NFPA 130 and Canada. This is not true for transit systems around the world, although some systems did adopt NFPA 130. So if the system is in Europe and it handles and it used European type cables and it does not follow NFPA 130, the guide will not be any help. It does help for transit system in the United States and Canada. Since the cable needs to be UL listed with UL type performance, North America type performance.
Let's see. Okay. And since this is for an enclosed transit infrastructure, I assume we're talking about tunnels. So what are the common cable applications we would see in transit tunnels?
So there are various applications and a lot of new applications that are developing over there with new technology. So the main common application is regular general purpose type cable, 600 volts and 2000 volts, instrumentation control and power that are used to power everything that is not special in the tunnel. The second type of cable is a fire resistive cable. These cables are designed to operate under fire condition for 1 hour per NFPA 130 in extreme heat, and primarily their purpose is to make sure that people can evacuate the tunnel safely and firefighter can enter the tunnel safely. They also control ventilation to evacuate smoke from the tunnel and keep the tunnel lighting on so people can exit the tunnel and firefighters can see how to fight the fire. Another common cable in transit tunnel is a signaling cable. Subway system the trains are being moved by the signaling system. That's how the controllers of the train knows where the trains are. If you think about big system like New York City, signaling cables are critical to make sure the trains do not collide with each other, that give enough space for trains to move forward or shift between the tracks. Another type of cable are the traction power cable. In the United States, most of train systems use a third rail power cables, and these cables are installed under the tracks in the ballast, and they are special construction. Another very important type of cable are communication cables. As technology moves on, there is more camera, more Ethernet, and other controls in the tunnels like axle counter that use communication type cables. These are not 600 volts or 2000 volt cable. They simply deliver high speed communication in their various standards and communication protocol. And the last cable that is used in the tunnel is for cell phone communication, and this cable is called leaky coax. This cable, as they say, they provide phone communication when you're on the train, and they are installed on the tunnel walls along the track, and they emit the energy to provide cell phone communication as a 4G, LTE, 5G, this type of communication.
Before you mentioned NFPA 130, so talk a little bit about NFPA 130. What are the requirements for that? And maybe highlight some of the ways that this document and NFPA 130 can complement each other.
So the requirement from NFPA 130 is that the cable be NRTL listed. NRTL means National Testing Lab, Nationally Rated Testing Lab.
Recognized. Nationally recognized.
National Recognized Testing Lab, I apologize.
That's okay. I work for one, so I know.
And a very common NRTL will be UL, CSA, or Intertech. The cable needs to be 90 degrees C insulation, which are very common to UL NEC type cable, NFPA 70, and they need to be wet rated. The reason for wet rating, tunnels are a wet environment. If the cables are installed in conduit or installed along the tracks, water will accumulate and cable may sit in water for years. So these are the basic requirements for all cables. Fire rated cables needs to survive for 1 hour in Euro 2196. And they are installed in a very specific way to make sure that they tested in 2196 under fire condition the way they are installed.
What typically do we see for the technology for insulations? Do we see a lot of low smoke, zero HAL? Do we see thermoset, thermoplastic? What are we typically seeing in these applications?
So for the application of general purpose and signaling cable and traction power and communication cable, those are in almost 100% they are low smoke, zero halogen insulation. Usually single conductor will follow UL44 for thermoset XLPO, low smoke zero halogen. Multi-conductor will have thermoset insulation and thermoplastic jacket for that are low smoke zero halogen. These are the main technology for this type of cable. Fire rated cable, on the other hand, they usually use silicone insulation, which is thermoset, and a low smoke zero halogen thermoplastic jacketed cable. So this is primarily the low smoke zero halogen. Although it's not a requirement in NFPA 130, this is what is used in North America tunnels.
And just to touch a little bit on well smoke zero hal, I know it's not mentioned in 2789, but perhaps, and for those who don't know, IEEE standards tend to go on a 10-year revision cycle. So this was published in 25, so we won't see this again until the early 30s. But at some point, I'm wondering if the UL 2885 LSHF program might be incorporated into this document. Because I know right now, well smoke zero hal, there's all kinds of different tests out there. I just don't know if this is something that would make its way in.
So because UL 2885 allows to mark the cable as zero halogen, and this is, look to me like in the future, it will be a requirement because everybody uses this type of cable. So there is no reason not to mark it accordingly to the NFPA 70 and UL standards.
Good, that's good to know. What are the UL CSA standards that are talked about in this document? I know you've mentioned them as NRT listed and tying to the NFPA 130. So what typically would we see, which standards will we see referenced here?
Yeah, so single conductor usually follow UL 44, which is a thermoset insulation. Multi-conductor will be UL 1277 tray cable or UL 1569 that are armored cable. Communication cable will follow UL 444. And then on the Canadian side, CSA will require RW90 for single conductor, RA90 for armored cable, CICS and ACIC for multi-conductor instrumentation cable, armored and non-armored. Communication cable will be FAS90. And then the standard that they follow will be NFPA 70 or the CEC, which is the Canadian code. And in addition to this type of standard, for signaling cable, IEEE 2789 add a reference to ARIMA manual parts in the communication and signal C38.
I just want to go back to one thing for our viewers who know UL very well. UL 1569, the title is metal clad, armored is UL 4. They tend to be interchangeable, but I just wanted to throw that out there so people don't get confused and think of UL 4 armored cable versus metal clad cable, but they're armored. So just wanted to make that clarification. Now you talked about fire rated cables, and this is, excuse me, this ties into the episode 1 that I did with Alex Marciano on concrete encasement. I want to talk a little bit about that, but I want to talk about in general about fire rated cables and how they're addressed in this document.
So it explained the fire rated cable and the requirement for FHIT, which is the installation method of fire rated cable. They need to be installed as tested to make sure they work in a fire event. Also, NFPA 130 give other option to use besides cables for fireproofing. IEEE 2789 explain the advantages and disadvantages of fireproofing, which are called wrap system, also concrete encasement, and a fire barrier and redundant system. So using cable usually gives you an advantage over the other systems, and IEEE 2789 explain all these advantages. In general, installing fire rated cable, it's probably the most common way to maintain circuit integrity under fire condition.
I think you'd agree that with the change in the 2026 National Electrical Code on concrete encasement for cable and conduit from 2 to 5 inches would make concrete encasement even less desirable now in tunnels and put people more in touch with using fire-rated cable. Would you agree?
Yeah, for sure. Installing 5 inch of concrete makes very difficult concrete encasement. It costs a lot of money, it's a lot of concrete, and maintaining the cable inside the concrete is also an issue. It's much easier to use fire-rated cable system.
But, okay. So does 2789 explain the different cable technology and compliance to NFPA 130 for signaling cables?
Yes, signaling cables follow Chapter 12 in NFPA 130. And as I said before, they need to be UL listed, 90 degrees C, and wet rated. NFPA 130 give and exclude signaling cable to be installed in conduit or armor. They can be installed on a messenger, usually on the tunnel walls. In United States, legacy signal cables are usually used with EPR insulation and low smoke zero halogen jacket. These type of signal cables, they do not meet NFPA 130, but they are used in many systems. IEEE 2789 explain the difference and give you the option of the cable types for legacy system and also for signal cables that comply with NFPA 130.
And also, I think it also deals with the ARIMA document as well, right? Because there's for ruggedized designs.
Correct. Some transit authority like the signal cable to have thick insulation and thick jacket, thicker than the required by UL standards. So ARIMA C38 manual parts 10316 and 10317 give you the wall thickness for this type of cable for 600 volts and 2000 volt, aerial and underground, and you can design the cable to be very robust just in case that the signal cable gets hit by the train or hit by something because of the critical function of the signaling cable. Authorities like the cables to have thicker insulation and jacket to be more robust.
Which costs us more. Yeah. Communication cables, there's lots and lots of different kind of communication cables. What specifically are we talking about for this application? Which types are we seeing?
Communication cable is a growing market. There is more and more communication system in the tunnel. Usually the basic communication will be Ethernet category cables like Cat5e or Cat6. It can be shielded as the train motors can make noise and the shield provide proofing from EMI, electromagnetic interference. There are other communication cable that are used in the tunnel, for example, axle counter that provide they're installed on the tracks and the system can see where the trains are with the axle counter. These are communication cables. So there are different protocols, could be RS-485, RS-232, maybe even field bus in some systems. Those are all fall under communication cables.
What about leaky coax?
So leaky coax is an interesting situation, is that leaky coax cannot meet NFPA 130 because it's not wet rated, it's not 90C, it's a different type of coaxial cable. And IEEE 2789 explains that and explains the construction of the cable and the fact that it cannot meet NFPA 130. I'm actually confident that in the future revisions of NFPA 130, it will give a way that you can meet NFPA 130 just by doing the flame and smoke and not by using the 90 degrees C wet rated cable, as this type of cable cannot meet that.
Okay, so questions are now for the field, if you will. in your dealing with the customers that you deal with in your day-to-day operations, since now this document has been out there for a year, have you seen any, have you had any interaction with customers over this document? Are they using it? Are they asking for it? Or are they aware of it?
Yes, when we discuss various application in tunnels with different engineering companies or transit authority or firefighter chief of firefighters, we tell them to read the document, understand what they need to be installed and how to comply to NFPA 130 with the different options. As different cable manufacturers have different solutions, and looking in IEEE 2789 give you a broad understanding what type of listings and cable types are available. NFPA 130 does not address that, but the guide is. So it's definitely being used, and it's gaining more popularity.
Excellent, excellent. And again, great job in doing this. So now it's time for a little marketing. Maybe you could just go over the types of products that we offer that would be chosen by those using this document. So by all means, let us know what we got.
Yes, for the general purpose cable, our cables are called firewall LZH, and they are 600 volts and 2000 volts. They can be single and multi-conductor with shielded pairs or power cable. The signaling cable and the traction power will also be from the same family of firewall LZH, and it needs to be discussed with the customer. Do they need to meet ARIMA or does not meet ARIMA regard to the wall thickness? Fire-rated cables, our product is called Vitalink, and we currently make this cable as a metal clad cable or as a single conductor RHW. We also have a fire alarm fire-rated cable that is under the product name of Hublink. It used to be called Vitalink CI. Now it's being under Hublink. Communication cables are also Hublink. And our leaky coax, we recently acquired a company called Trilogy, and they sell a special product for leaky coax that actually the insulation is made out of air. So we can cover all different options of the cable that are installed in transit tunnels.
Excellent, excellent. Well, Gil, thank you very much for joining me today. Very informative about 2789. I know it was a long process and COVID interrupted it, but now it's out there, it's gaining acceptance, and it's a benefit to the industry for sure. I'll leave you with any closing remark you may want to have before we sign off.
No, I think we covered most of the issues, and I hope everybody stay with compliance of NFPA 130 as a safety standard. It protects the passengers, the transit authority, and safety first. Thank you.
All righty. Well, thank you again, Gil, and thank you, everyone. And we will see you on our next podcast.